I can't clear my throat enough. Okay, this question is question 6, and it's about the factors that regulate cardiac output, and we have to list the mechanisms through which they do that. And I'm specifically saying we want to increase cardiac output. So if you recall, cardiac output equals heart rate times stroke volume, and stroke volume equals end diastolic volume minus end systolic volume. These definitions again, stroke volume is the amount you're pumping out per contraction from each ventricle. End diastolic volume, when blood is coming into the atrium and then going into the ventricle is relaxing. So at the end of diastole, how much blood has filled up in this ventricle? Well, when the ventricle contracts, it sends stroke volume out either through the pulmonary trunk or the aorta, but what's left behind is a little bit of blood, and that's called end systolic volume. And then there are things that are going to affect end diastolic and end systolic volume, which we're going to be talking about. But what are these factors? There are only 4. So if you can remember these 4, you're going to be good. If we increase our amount of exercise, or if we decrease heart rate, or if we increase, we're going up, down, until the last one. If we increase the amount in our blood, the amount in blood of T4, which is thyroxine, or epinephrine. Now, what we're going to find with these two things, T4 and epinephrine, they've got something in common with hypercalcemia. So we're going to, they don't cause hypercalcemia. These guys, hypercalcemia, thyroxine, and epinephrine are going to have the same effect on the heart. And our last one is going to be exercise. Same as the before, increasing exercise, but this is going to be a different route through which exercise is going to regulate the cardiac output. Exercise, being scared, or having anxiety, these things right here we're going to find are going to affect and increase cardiac output. So let's start over with our first got a dog here, with our first exercise. How does this going to affect cardiac output? Because that's what we're looking for. And so along the way, we're either going to be hitting any of these guys up here. So if we increase exercise, what we do is we return blood to the heart faster, because our muscles are pumping. We've got the respiratory pump. We've got everything going. Somebody wants attention over here. We've got everything pumping the blood back to the heart faster. So that increases the venous return, which is fast as blood come back to the heart. And if we increase venous return, what we're going to do in turn is we're going to increase the amount of blood that's in the end, that is in the ventricle at the end of diastole. So we're increasing end diastolic volume. Well, the same thing almost is going to happen with decreasing heart rate. 2 ways we can increase our end diastolic volume. We can either put blood into the heart faster, or we can slow the heartbeat down, because if the ventricle is going very slow compared to this, it has more time to fill up with blood. And so that increases the end diastolic volume. So if we drop our heart rate down, we're going to increase that end diastolic volume. Now, what's happening in this next row? These are the mechanisms that I'm doing right here. We're going to work on cardiac output in the next row. What happens if we have excessive thyroxine and excessive epinephrine? And what these guys do is they're going to cause the heart, when it comes to cardiac output, it doesn't increase cardiac output and heart rate. It increases stroke volume. And the way it does that is it's a more forceful contraction each time the heart contracts, because the heart has more availability of calcium. And if you remember the muscle chapter, calcium is very important to muscle contraction. And so if we increase our calcium, either for some reason we have increased calcium, that's what hypercalcemia is. Maybe we've got hyperparathyroidism, who knows? But if we have increased calcium, or if we have these 2 hormones, thyroxine and epinephrine, in excess, they're going to cause an increase of calcium. And what that's going to do is it's going to increase the contractility of the heart, meaning the heart actually there's more bang for the buck with each actual contraction. So what does increasing contractility mean? Well, if you increase contractility, we're sending more blood out of the heart with each contraction. And what is that? Well, that's stroke volume, the amount of blood that's sent out with each contraction. So how is actually contractility doing that? Well, it's leaving less of this behind. Each contraction sends blood out, more blood out. And so what's left behind? Less end systolic volume. So contractility is going to decrease the amount of end systolic volume. If you want to play around with regular numbers like 2 and 1, and then figure out what happens if you increase this, you can play around with simple math to figure this stuff out. Let's do one example of that. These numbers are made up. They have nothing to do with the heart. But if stroke volume equals end diastolic volume minus end systolic volume, maybe end diastolic volume has to be more than end systolic volume, by the way, because the ventricle's filling up and then it contracts, and what's left behind is end systolic volume. So it's always going to be less. So if we make end diastolic volume 2 and we make end systolic volume 1, then our stroke volume is 1. So if we increase contractility, what we're doing is we are contracting more forcefully, sending more blood out, so less is left behind. So which numbers with contractility is this affecting? This one. So if we're decreasing this, let's pretend like we start with the end diastolic volume of 2 again, and we decrease our end systolic volume, maybe cut it in half, then what is stroke volume now? Well, 2 minus 0.5 is 1.5. So we've increased stroke volume. That's how contractility works. If you need to reason your way through here, because this is hard to memorize, that's fine. But this guy right here, this will help you knowing this equation if you want to reason your way through it instead of just memorizing. So if we increase end diastolic volume, or if we decrease end systolic volume, what that's going to do is that is going to increase straight up stroke volume. And if we increase stroke volume, it's directly correlated with cardiac output. So that is going to increase cardiac output. So that's how those first 3 chains go into effect. The last one, the exercise, being scared or anxiety, what this is going to do is it engages the sympathetic nervous system. And we know when we're in fight or flight, first of all, if we're in fight or flight, I don't want to I will tie this into effect. When we engage our sympathetic nervous system, we will increase contractility, because what we're doing is we're increasing the amount of epinephrine, right? And so realize that increasing your amount of sympathetic nervous system will increase contractility, and that alone, if we follow this pathway, will increase cardiac output. But another thing that will happen here is that we will increase our heart rate. And anytime we increase our heart rate at the same time as contractility, remember that heart rate up here, I'm up here now, heart rate, if we increase it, we're going to increase this. So increasing heart rate leads to an increase in cardiac. I put an O2O down there. Sorry about that. I'm used to doing carbon dioxide. That's increasing carbon dioxide. So this is what your answer should look like. You don't have to have the numbers or the stuff at the top. Those are notes for myself when I'm doing this. This looks very similar to a slide you have in your PowerPoint, but the slide might be slightly off. I'm not sure, but this is the answer for number 9. Okay. I hope you're going to come to the study session if you have questions.